Today, we're going to design a few actually functional things. So in preparation to going to 3D Printopia, I want to bring these hex drivers because I use one of them to assemble the dummy 13 for one, and then I use the other for other various things, but I want to bring all 6 of them. I have 3 sizes of these smaller ones and then 3 sizes of these bigger ones. For the brief moment I looked online on printables, I didn't see any that had made a case specifically to enclose these. Like I've seen, things that people have designed to hook to a honeycomb wall or a multi-board or something like that. But I didn't see anything for a case. So, and even if there is one out there, I feel like it's a good exercise to design it anyways. So, I usually don't look very hard for a design online because I just feel like, if I can't find it immediately, then I may as well just design it myself. It's good practice. I need the practice. If anything, if Blaststream taught me anything, it's that I still have a lot to learn about Fusion. So yeah, that's where we're at. Aside from that, I have this power strip that I acquired from my mother-in-law, and it has these brackets. So this bracket fits right in here, and it's kind of a dovetail shape in here. And, it's designed to screw onto something, but on my metal rack back there, there's nothing to screw onto. It's just metal. I don't want to tap metal. So I was thinking I could design a 3D print that could fit in here, similar to these, that can have a magnet glued in, and I could just put several down here and then just attach it to the side using magnets. So that's what we're gonna do. All right, so why don't we get into it then? Cry a little bit. All right, so hey Piled, welcome in. Thanks for joining us. What would you guys like me to work on first? Do you want me to work on the dovetail attachment for the power strip first, or the case for these LDO drivers? Tell me how to live my life, please. Either way, I'm going to need my handy calipers. Yeah, the TPU as a gasket, that would be a good idea, especially if you want something airtight. Case for the drivers? Driver case. Okay, we'll work on that first. Okay, so, first things first, I want to measure the dimensions of the big one and measure dimensions of the small one so that I can put those in as parameters in my software. Okay? So first, let's just get a rough diameter here. Mr. Excuse with the resub. Thank you so much. All right. So this is roughly 18.4 millimeters. I mean, it's gnarled, so it's not like it's going to be super accurate. But we don't want it to be a snap fit. So I think 19 millimeters, but that only gives us 0.6 millimeter clearance altogether. So let's go 19.5. Let's go 19.5 millimeters. So let's go here. Oh, it's showing me, don't show this again. It's showing me new stuff of how to do those. Okay, so let's say LDO. I'll just do handle, large handle, L handle diameter. And did I say 19.5? Let's go 19.4. How you doing, Mr. Excuse? Okay, so we got the diameter of this. Let's do the diameter of the smaller one now. And this one is roughly 14.4, 14.5. So let's do 15.5 for the smaller one. Small handle diameter. Did I say 15.5? Ha! 15.4. Yeah, I need to organize my workshop too, but it's never going to happen. I feel like every time I get it looking good, I get tired and I'm just like, yeah, it's good enough. Okay, so now I want to measure the length of the handle and then also the length of this driver. So we have about 87 millimeters. So let's add about a millimeter there. So large handle length. And it was, did I say 87? Let's do 88 millimeters for the length of it. And then let's do the small one. This one is about 62.2, so I think if we do 63, that should give us plenty of clearance. Small handle length, 63. Okay. And now, obviously, each size, so this is a 2.5 millimeter driver. The 3 millimeter or the 4 millimeter is going to be thicker, so I don't want to measure based off of that. I'll probably just have a channel that's just a generic channel that all three of them will fit in. That way they don't have to be put in a specific sequence. I know a lot of cases do have a specific order of putting the drivers. But just in case, if I release this, if people like their drivers going from small to big or from big to small, they have that option. So all three of them are going to be about the same. So I think that channel is probably going to be about, let's just do 6 millimeters. I feel like that's very generous clearance for that. Let's just call it shaft diameter, 6 millimeters. And then we need our length. Okay, so I'm going to use this part of the caliper. Or I could do this part of the caliper. This is probably going to be easier. Okay, so that's about 85.3, 85.4. Notice what I'm doing with the caliper here. So you can measure from... For those who aren't familiar with calipers, there are various parts of the caliper you can use to measure. There's these 2 points that can measure the diameter of a hole. There's these two that can measure not a diameter, measure something that's like a hole or inside of something. And then these can measure the outside of something. But you also have this, so the distance between this and the end of this is a measurement. Or you can measure between this and the end of this. That would give you the same measurement as this. And if you guys think I'm an idiot for how I'm doing this, feel free to tell me because I am self-taught. Okay, so about 85.2 for that length. Let's do 87. Okay, so large shaft, length, 87. Now we need the small shaft length. Oh, let's do this. So that's about 47. So we'll do 48, 40. Let's do 48. Small shaft length, 48. Knight C142, thanks for following. Thanks for the follow. Only fancy ones have the top hole? I wasn't aware of that. So by the top hole, what do you mean by the top hole? Are you talking about this distance thing? Make it hold a dune pile. We're talking about how bad we are at organizing our workspaces. Okay, so coming back to here. Okay, so we have all the dimensions that I feel like we'll need. I want it to just open like a book. The slot in the back. Oh, you mean this slot here? This thing. Is that what you're referring to? Oh yeah, excellent, Knight. I've been considering, so it's great. SolidWorks just, I can't remember how long ago they started it, but they have a makers tier where the yearly cost for it isn't thousands of dollars. It's only like $42 or $48 for the year. But if you make more than $1,000 in that year, you have to use their commercial license. So I've been considering learning SolidWorks just to stream it. But I wouldn't be able to use SolidWorks for my models because I make more than that in a year with my models. So I would have to use it strictly for streaming. And then if I design anything I want to release, I have to redesign it in Fusion if I want to release it and earn money off of that. So that's something that I'm considering. Let me know if you feel like that would be something you'd want to watch. If you want to watch any SolidWorks stuff, then if I get enough feedback that you want to see more SolidWorks, I can pull the trigger on that. I think I can afford that yearly cost. I'm a thousandaire. That's right. I'm so rich, Liz. Welcome in, by the way. So yeah. So let me know if you want to see SolidWorks stuff specifically. And if I get enough feedback that that's what you want to see, I'll pull the trigger on that. Yeah, that's fine, Knight. That's fine. Thanks for lurking. My thoughts on Shaper 3D. I haven't tried it. Shaper 3D is an online source, right? It's an online tool. If you want to keep your files to yourself, I wouldn't recommend an open source software like that. But if you don't care about the community being able to access your files, or if you don't care about them being public, then it's a really good option. I did look into plasticity briefly, and that does look like something I'd want to use. It's a one-time cost to get it. However, there's only a trial period. And where my goal is to teach other people how to use CAD, if I'm using plasticity to do my CAD work, then I'm reliant on those who wanting to follow along purchasing that, or at least, doing the 30-day trial. So I might get plasticity just to, like, if I want to make a quick model and I want to use those tools, then I would use that. But as far as streaming CAD design, I'm kind of heavily leaning on Fusion because there's a free version for everyone out there who wants to use it for personal reasons. Shaper 3D is closed. Okay, I must be thinking of something else. If Shaper 3D is closed, as you pay, then that's fine. Hey, Matt Guy, welcome in. Thanks for joining us. Okay, so for those who have joined us, we are making a case for these LDO drivers. I just put in all our parameters, and we're ready to start designing. That's right, Piled. I am thinking of Onshape. That's right. I've never tried Shaper 3D. I got on Onshape once just to test something out. Someone asked if there is a possibility of doing something, and I was like, oh, let me see. And I just created an account real quick and tried it out. I'm like, yeah, it works. So I haven't tried Shaper 3D, no. All right, I'm gonna save this so far. Even though I haven't done anything, I've added some parameters. Let's just call this LDO driver case. I've seen some, I haven't tried piled. I've seen stuff that you've posted about it, and it looks interesting, and I might try it out to see how it goes. So, if I have time anyway. All right. Okay, so let's start off, let's just start with a sketch here. And pro tip, actually, so if you're not in a sketch, if you hit a hotkey for a sketch-specific feature. So, for example, if you want to do a projection or a rectangle or a circle, and that hotkey is not related to any of the features for 3D model, then it will put you into a sketch when you select a plane. Mr. Excuse, if you go on my Discord, Piled actually created a post for it under, I think it was under self-promotion, was it? Yeah, Piled, if you want to post a link to your Discord, then they can join it as well. That's fine. And then you can learn more about that. So, again, here, if I'm going to hit R for rectangle, now it's going to ask me to choose a surface. So I'm going to choose this bottom surface. And look at that. It already has the rectangle feature enabled. I'm going to choose center so that, you know, the difference between 2, 3-point, and center, if I do 2, then it's going to create a rectangle from one corner to another. If I choose 3, then I can make a rectangle like that. Or I could do it from the center and do a rectangle like this. I'm going to hit D for dimension. And this is going to be, let's see, we want, let's see, large driver length. By the way, I forgot to add these parameters, so you can actually add parameters on the fly as you're creating them. So large driver length equals large handle length plus large shaft length. Okay. Yeah, let's just do that. Okay. So now if I hover over this, it says L driver length : and then it gives me the formula. Hey, Jupiter Robotics, welcome in. And so you could use that from now on. Now, if you did a few actions before this sketch, you won't be able to go back in time to use that variable because that variable was created in this sketch. But since this is the first sketch, you can't go back in time further than this. Well, you can and do stuff, but I'm not going to. Okay, so that's how long the driver is. And this, I'm just going to say a large handle diameter. Okay, so this is going to be one slot for one driver. Now what I actually want to change, I'm going to delete this. Let's copy that. Because I want this to be longer than the driver with the handle, and I want this to hold all 3 drivers. Now, what I plan on doing is I want them to stack like this. So I'll have 3 big drivers on one side and then the 3 little drivers on the other, and they'll kind of intersect like this. So that's what I plan on doing. Okay, so instead of doing the left handle diameter, let's do the large handle diameter times 3 plus, I don't know what the spacing should be. Should we do, because I want enough spacing so if I put my fingers in there, I can grab it. If there's not enough space between the handle and the edge of the case, it's going to be harder to grab. So I'm just going to say, I don't know, 15 millimeters. 15 times 2. I'm going to put this in parentheses 2, handle diameter times 3, plus that. Okay. Now I'm going to do this, which is, so we have our handle length plus shaft length, plus, and then we'll do 2 times, what was it, 15? I could have easily just put 30, but whatever. Okay, so I think that's going to be our case dimensions. Okay, let's just make our box real quick. So how tall it is, I mean, I could make this part as tall as the diameter of this, but I kind of want it to poke out a little bit so that, let's go here. So I'm going to have it poke up a little bit. So it's probably only going to come up to here. Plus I'm going to have little holes to be able to grasp it with my hands. Hey, Diablo Spawn, welcome in. Thanks for joining us. Yeah, Bearded Pumpkin. It's going to be my nickname now. So let's just do, but we also want padding at the bottom of the case as well, because this isn't going to be flush with the bottom of the case, is we're going to have some space. So what if we just did the large handle diameter for the height? I'm just double checking what that height is, 19.4. That's divisible by 0.2. So that would be printable. And if I do that height, then that would allow me to move this up from the bottom a certain amount to be able to do that. Well, I know Floppy Pumpkin Patch. Okay. Now, I'm going to come here and add my variable. So, I'm just going to call it spacing 15 on each side. And I'm going to come back to my sketch to make sure that I'm using spacing instead of the arbitrary number. Thanks. Oh, come on. Oh, please. Thank you. All right. Oh no, speedrun, Jupiter Robotics. Okay, Jupiter Robotics, you tell me what you want me to design and I'll do my best to, oh, Bearded Pumpkin. Oh my goodness. Okay. Okay, of course. That's gonna be a challenge. Okay. All right. Well, let's save this. Whoops, that was interesting how that happened. All right, let's open this up. Am I allowed to use an existing pumpkin to make it bearded? This is not going to be a floppy driver holder. It's just the way it is. Hey, Realizes, welcome in. Okay, so am I allowed to use an existing pumpkin to make it a bearded pumpkin, or do I have to start from scratch? Yeah, she did. She's making things a little difficult for me. It'll cost me 5 minutes. So I'd only have 10 minutes to do the... Okay, I accept that cost. I accept that cost. Okay, let me get my timer running. Uh-huh. Okay, got my timer ready. Let's get this stuff out of the way. This is gonna be great. Okay, be ready? Should I get my intense music going? Should I get intense music going for this? Okay, playlists. Pause that. All right. Jeopardy theme song? No. Okay. I will try my best to do a bearded pumpkin. This will be interesting. Okay. 1, 2, 3, go. All right, timer's started. I'm gonna find an existing pumpkin. Okay. I'm gonna grab this one, the lid and the stem. Copy. New feature, paste. Okay. Finish base feature. Okay, so going from the front, let's make those go away. I'm gonna start my form tool. It's the best way I know how to do a beard like this. Okay, let's just go off of this. And let's see. Might have to. Let's go with that for now. I'm gonna adjust these to make it more uniform. Okay. Here we go. And then we have... Okay. So we got an interesting beard going here. Let's do this. There we go. Let's undo those. Okay, let's just work off of this. Finish that sketch. Let's do an extrude off of this. Let's go like this. 40, I think, is sufficient. Nope, I don't like that. Let's go 30. I think that's sufficient. Okay. I'm not sure how the whole thing is going to work with this, especially with that going there. Let's delete that. I can work with that later. Fill hole. This one. Okay. I don't want to keep creases. Hold control. Fill that second side in. That's looking a little hairy. Okay, let's not do that. Whoops. Let's just keep it like that for now. Okay. Now if I do a separate fill hole, select this. Keep creases. Nope, let's just keep it at that. Okay. Let's see. I've got 6 minutes left. Okay. Okay, here we go. Now I'm going to subdivide. Let's go. Yeah, that might be good. Okay. So now I can take these. Let's pull those out. Change our selection so we don't select through. It looks like that's already done. Okay. Okay. Uh-huh. Okay. This is not how I did my floppy beard, by the way. My floppy beard was much more thought out before I finished that. Okay, let's move. Select through. Move these back. Okay, I probably have to smooth that out. Okay. Move this back. Okay, where are we? Got 4 minutes left. Okay, we're moving, we're moving. I'm not liking how this is looking though. Okay. Let's move this forward to be on the pumpkin right there. Okay. Okay, that's looking good. Okay, let's move this back a little. Okay. Now, I wonder... Let's do this. I thought that would be the case. Let's delete all those. Don't select through. Come on. Wow, this is doing some funky things. This form tool is not very forgiving, by the way. Not very forgiving. Okay, let's see how the fill hole thing will work now. Let's do reduced star. I think, maybe that'll work. Yeah, look at that, it worked. Okay, and I'm going to do, let's see, how much time do I have left? 2 minutes. Okay, so I'm going to do... We got a subscription from Additive Adam. Thank you so much. Okay, I'm going to make that go away so that I accidentally cut into it. Let's do this thing again. Okay. Okay. Whoops. All. Nope. I guess we'll do 2 sides. Distance. This way and this way. Cool. And I guess we'll try to do a fillet, see if that works. I don't care about that side. 5. Nope, doesn't like that. 1. Okay. I'm going to take my pumpkin. I'm going to do a combine. Okay. You go away. This is not at all printable. Oh. There. Got 30 seconds to go. There's my bearded pumpkin. I mean, it's okay. Not bad for 15 minutes. 10 minutes, actually, because I used an existing pumpkin, which I don't think I could have done it that far if I started with a pumpkin from scratch. Okay, let's save this bearded pumpkin. This is not at all printable. I mean, you'd have to put supports around here, and there's no spot. There's no spot there where it can just print. So there you have it. That was fun. Let's change the music back so it's not so insane. Okay. All right, let's go back here. So thanks Jupiter Robotics for that. If you want the file, I can send it to you. Just send me a DM. And I'll just send you the STL. I don't plan on doing any test prints of this. Oh, yeah, nice beard. A hinge so the beard can print on the build plate? I mean, that would be nice. I didn't have time for that. Floppy beard fun. I mean, I do have a floppy beard. I could have just, like, created some connectors on this and just imported both models. Magnets? Yeah, we could put magnets on there so it can attach to the pumpkin. These are all good ideas. Hey, Super Positive, welcome in. So that's how pumpkins grow beards. That's right. I'm going back in time, reading comments here because I was focused. This is bizarre. That's right. Phil Hole. That's his name. Hey, Manly Mutt, welcome in. Hey, Steve Poole. Thanks for joining us. All right. And I don't know if I said hi to Technoside yet. Hello, Technoside, in case I forgot. Yeah. So there's that. We're done. Okay, back to the case. Oh, this is not working out. Okay. All right, so we have our case here. So I'm going to extrude this up. Did I already do the extrude? I already did the extrude. Okay. Now, before I do anything else, which, by the way, let's see. Oh, we got a hype train. We got a hype train. How did we get a hype train? You guys are crazy. Add a support block under the pumpkin, and then you'll be able to sit on a shelf. Yeah, we could do that. I mean, you know, if Jupiter Robotics, if you want the file as a step file, I could send that to you like that as well. So if you want to do anything like that, you're more than welcome to. Thanks for the bits, AWZ, 150 bits. Thanks for the gigantified emote, Additive Adam. He's got a cute ferret in chat. All right, so hey, LTX Designs, welcome in. I think I just realized something. I forgot to start something, start an application. Let's get Lumia running, because I forgot to start Lumia. There we go.
Neat.
Lumia is here. Neat. Thanks for the gigantified shoosh, Pezlas. I appreciate that. Which, by the way, if there's anyone here who doesn't know who Pezlas is, and you're interested in 3D printing, she does some awesome streams talking about different filaments you can buy from Polymaker. She also has a show called Z&Z that she hosts with Zombie Hedgehog, and they talk about common things about 3D printing, you know, gotchas and all sorts of stuff. So, yeah, be sure to give her a follow. Thanks for the bits, Pezlas. 10 bits, 11 bits, 12 bits. She's giving all the bits.
Boop, 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 boop.
Bearded blaster win. Of course. Thanks for the gigantified heart, Sharon. I appreciate that. Boop, 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 boop. Follow who now? Oh, so we have Pezliz. So give Pezliz a follow, and there's also Zombie Hedgehog. So you can give both of them a follow, and they talk a lot about 3D printing. Zombie Hedgehog talks a lot about technical aspects of 3D printing. He builds 3D printers on his stream and talks about filament as well. And then in the Z and Z show, Pezliz and Zombie will actually choose, based on they change back and forth each week who runs the stream. So one week it'll be Pezliz and Zombie Hedgehog will be there, and the other week it'll be Zombie Hedgehog and Liz will be there. So highly recommended. They talk a lot about a lot of cool filaments and cool printers out there. And then even any problems that they've had and what they had to do to solve it. All the bits! We're getting so many bits! Milk money. 13 bits for milk money, 14 bits for iced milk, 15, 30, 12, 31, 8 bits for Mr. Excuse. Let's go. Thanks for the bits, everyone. Appreciate it. All right. Okay, so we're 61% into level 1 hype train. Thanks for the 14 bits, AWZ. I appreciate that. They switch off. That's right. That's right, Manly Mutt. Yeah. So I love watching their streams. Very informative. Okay, so let's start here. Let's put in our stuff. Yeah, thanks for the hype train message, added Adam. I appreciate that. It's a neat hype train, that's for sure. That's 100% for sure. Now, with this, we want to be able to have the big drivers on one side and the little drivers on the other. Thanks for the gigantified hi, Pezliz. And so I think, I don't know, what do you guys think? Should I mean, it can be mirrored in the slicer, so I guess it doesn't matter. Excuse me, it doesn't matter. But before I do anything, I'm gonna add a fillet to these corners here. I just realized I don't have select through for my filters, so I can select through the object to the edges, and I don't know, 3mm sounds good to me. Thanks again, everyone, for the hype train. I appreciate it. Y'all are awesome. 5 more bits from Sharon. Thank you. Barking Cauldron. Okay, and then I'm going to add a chamfer to the bottom here. Let's just do 1mm. I feel like that's sufficient. And then another chamfer here. If I was going to make a shell, I would have done the shell already before I do this, but I don't know, 0.6 I feel like is sufficient for that. Okay, so what I'm going to do is I'm going to add an offset plane from here, and it's going to be negative spacing, so that's 15mm over, and that's kind of where the length of the shaft is going to start. Now, I can't remember, when I did this, I didn't add any clearance, so 2 times spacing, and then we have, oh yeah, we added our clearance to the handle length and shaft length already. That already has a generous clearance built in, so we don't have to worry about that. I just hit Control-Z to get back out of it, by the way. So I'm gonna start here, and I'm going to create a sketch on this plane. Now, to know where we are at inside this sketch, so I can fully constrain my sketch, I'm going to use this intersect feature here. I'm going to select this top plane here, and maybe I'll select the bottom one as well, just so I can make sure that it doesn't go below that. But if I Now it's going to be 3 circles. I'm going to create 3 circles and then extrude them past or extrude them forward. And that'll be where the handles of our driver will sit. And because there's 3, we could have one in the middle and then one over here and one over here. So I'm going to create, let's create a line first. I'm going to create a construction line just so it doesn't create any profiles that we don't want. Now I'm going to hit C for circle. And I'm just going to create a circle arbitrarily right here. And let's say large handle diameter right there. And I'm going to hit D. Now, pro tip, if I try to dimension this between the circle and the bottom here, you'll notice, I'm going to hit enter here and move this out of the way. You'll notice it does it from the center of the circle by default. If you don't want to do it from the center of the circle, I mean, you can always do math and just figure out, well, if the diameter of the circle is this and I want it this far away, then you can just put in a formula. However, if I right click on the circle, I can choose pick circle arc tangent. And now you can see, whoops. So I'll select this, right click this, pick circle arc tangent. And now it does it from the tangent. I think 5 is good enough. I'm just flying off the seat of my pants. But math is hard. That's right, math is hard. Who wants to do math? Math is lame. Okay. So what I can do here, I can create 2 more circles if I wanted, or I can do a rectangular pattern. So I select this, the direction, I'll just select this top line here, and I'll pull. Now, I don't want the circles to appear over there, so over here, I can change from one direction to symmetric. Okay, and notice that I have extent selected. I can change it to spacing, but since I know that I'm only gonna want 3 altogether, I'm gonna keep it as extent and just go like this. And I think that's great spacing. Let's just go with that. Okay. Now, when I chose how thick this was, I didn't consider the spacing between the drivers. So initially it was the diameter of the handle times the spacing times 2. So it's only, taking into account the spacing on each side here. I need 2 more. So I'm gonna finish this sketch and I'm gonna go back in here and modify this. And instead of spacing times 2, I'm gonna do it times 4. Okay. And now I can go back and notice that my timeline is still intact. There's no red. And now I can click on this little icon in the middle here. That's my pattern. I can double click that and I can drag it. Now, instead of just giving an arbitrary number for the distance, I'm going to change that to spacing, because that determines the spacing between each instance of whatever's being generated from the pattern. And for the distance, I'm going to start, so we're looking at half the circle, so it's taking into account the circle. So I want to go half the circle plus the spacing. Or no, I'm thinking of that wrong. If I go spacing, then you'll see where the circles are going to appear, plus large handle diameter. Okay, there. Now, ideally, from here to here will be whatever the spacing value is, and from here to here will be whatever the spacing value is. And if I do a measurement, can I go based off of this? There we go. That's 15. Okay. I go based off of these 2. That's 15. I don't know how well you can see that. It's the text is kind of. Here, let's make the body go away. There we go. So it's 15 between those, 15 between these, 15 between the edge of this and the edge of the box. Right? Okay, so by using the parameter. Now let's change something. If I go here and go into change parameters, what if I want to change the spacing to 14? I'm gonna do that again, and hopefully my face isn't gonna hide it. You see that? How the pattern changes. The pattern itself gets skinnier, and the box gets skinnier. That's parametric modeling right there. You change a parameter, and everything changes along with it. Put a point on the edge of the circle cutout. That way you have a reference point. I'm not sure what you mean. Okay, so I have my circles here. Now, you'll notice the circle kind of goes in at this point. If I were just to extrude these, if I wanted to get the driver in, it's going to come in from the top, and this outer part of the driver would have to pass this part, which is closed more. So what I want to do is I'm going to create a line here on the outer parts of the circle, just so it's easy for me to get a reference there. I'm just going to draw a line up there, and then I'll just draw a line across. Okay, so now you can see, let's make this go away. You can see that I can select those now as profiles. But now, am I going to have to do do that same thing to these ones? No, I can go here, double click this pattern. For objects, it's waiting for me to select more, so I'm going to hold Control and select these and hit OK. Bam. To keep the distance between the edge and the wall of the case. So the distance between the wall and the case is going to be consistent with my parameter. Right now it's set at 14. So let's bring the case up. If I bring up my measuring tool, I hit I, but you can click it up here. I can click this circle and then click this edge here, and it says 14 millimeters. Or I can go between these two circles and it's 14 millimeters. Now, if I change my parameter, let's say to 20, let's bring this back up, bring back our measuring tool. That's 20 millimeters now. So I don't need to add additional points of reference here because my math is doing it for me because of how I have it set up with my pattern and everything. I'm going to change this back to 15. So if I just put a point out here, so you're saying, let's delete these. Oh dear. I'm gonna just hit undo. There. Okay, so delete those. So you're just saying add a point right here. How do I know that that's going to be tangent? I mean, I could have just created a line here and then used a tangent constraint here, and then I could trim this off to make sure it's not a lingering line there. I mean, I think, can the parameter panel stay open? No, not really. I mean, I can move around, but construction line. Anyway, let's undo that. Okay, so I'm gonna edit this pattern again. Make sure I have these selected. Okay. All right. So we have those extrusions that we can do. So I'm going to hit E. select these. And I'm gonna do the distance of negative large handle length. Boom. Yeah, it's especially hard to explain things in chat. But if you want to do like, I don't know if I'll have time to meet with you after this, but if you want to do like a quick like video of yourself showing me, you could do that as well. Okay, so now I'm going to do another sketch on this surface here. And let's project these. And I'm going to do, so we want to do a shaft diameter here. Now, instead of just doing the same thing where I had to do a pattern, it would be much faster and still just as effective to just use my projections to create more circles here. So shaft diameter. Okay. Now, we don't want to have to take the driver and have to feed it in like this. So we're going to do the same thing we did before and pull this up. Now I'm not going to do the construction lines like I did before, just to show that it can be done. Notice that one automatically applied a tangent constraint, and that's because I hovered over the midpoint of the circle, and notice there's a dotted line as I move over. And then as soon as I clicked, it just automatically assigned the tangent constraint because of where the position of the line is. But if you have a line where that wasn't the case, you can come up here and click on tangent, select the line and the circle, and there you go. So I'm just going to do the same thing here. I'm going to hover over this, go over, click, and notice there's a tangent symbol next to where I started the line. So as soon as I click OK, it's going to not only apply the tangent constraint, but right next to my mouse, there's a right angle symbol. So it's going to apply a perpendicular constraint between this line and the line I'm connecting to. So I'm just going to do that same thing here. So those constraints get added automatically. And then I'll just click here to add my constraint there. Okay. Now, what I could have done instead of this, I could have done one extrusion in the middle and then done my rectangular pattern like this to duplicate that extrusion over 3. So that may have been a better option. So you can do that too. But I'm just going to do this, a negative shaft length, large shaft length. Boom. Now I'm curious if I had my math right. I'm going to get out my measuring tool by hitting I. I'm going to select this face and this face. Look at that, 14 millimeters. Let's select this face and this face. Look at that, 14 millimeters. My math was right. Okay. So ideally, when I set the drivers in here, because of the generous clearance I gave here, the driver should sit comfortably against this surface, and there will be still some space for the hex driver part to fit in here. The math is mathing, that's right. Now let's go from this side and oh, there's one problem I just realized. We have spaces for 2 small drivers, but we need 3. I have 3 of these. So we're going to have to change a couple things. One, we can have the 2 drivers right here, but we're going to need another spot over here. So I wonder, and we'll also have to put like thumb holes right here so we can grab the drivers. I wonder what's the best way to make this looking pretty. Hey, Fern Dog, welcome in. Thanks for joining us. Okay, so let's just change it. So we could have one small driver here, and one here, which means the spacing is going to have to be ×5 instead of ×4. So if I double click this, I'm going to change this to ×5. Now, I could make that a parameter, but I'm lazy. Now, it made it wider, but because of how I did the pattern, it's keeping it in the middle. So I'm going to come back to this sketch, and instead of this construction line being right in the middle, I'm going to move it over. Whoops. So I'm going to click on this triangle, which is a midpoint constraint, delete it, and now I can move it over. Oh, because it's attached to this. Oh, okay. I'm going to make sure this stays vertical. So I selected the line. I'm going to click on horizontal constraint. Now this line is attached to the origin, and this is a coincidence constraint. I'm going to delete that so I can move it over. Okay. And now I'm just going to do this. I'm going to project this edge and make sure this is spacing distance. And I'm going to change this spacing plus handle. Okay, that's fine. Okay, so now they're over more. But there's one thing I forgot. So I added an extra spacing, but I didn't add an extra handle diameter. But because the handle is the small handle, I'm going to use a small handle diameter to do that. So here, I did the spacing ×5 plus small handle diameter. There. That way we can do a small handle diameter on this side plus the spacing. So hopefully my maths and that this works out. We'll see. But yeah, we'll have a small one here, small one here. Oh, but my math isn't going to match because the small handle diameter would intersect with these. So I'm going to do this because my math isn't mathing. Let's just add some rectangles here because I need to visually see this. And then we have smaller rectangles here. Okay. Spacing. And this is the large handle diameter. I don't care how long this is. Should have just done a pattern, but whatever. Okay. So we have that spacing. Okay. Let's add construction lines between these. Small handle diameter. Okay. Make this horizontal. This pulls down, this pulls down. Okay. Now I'm going to grab the distance between these, which is 0.7. Okay, so that's kind of where I want it. There. So, oh, and this was supposed to be there. Okay, so that's kind of what we want. So that determines how wide it is. Cool. Now if I hover over this, this is D42. So this is me getting pretty messy. Hey Moji, welcome in. Thanks for joining us. Hey GTR Dad, thanks for joining us. So this is gonna be a little messy, but I don't care at this point. So D42, just remember D42. Okay, so we're right here, and I'm going to, what did D42 measure? Oh, the distance between this and this. Okay. Okay, so I'm going to create another plane, negative spacing, okay, to start right here, which happens to be right where those are. Now, I could have just added a sketch where these driver faces are, but in case I want to change those to be longer for some reason, I always want this to be whatever the spacing value is from this edge. So let's create a sketch here. Now I'm going to project this point. I'm going to project this point and this point. It was D42, right? Okay, so let's do an intersect. So I'm gonna click on intersect and select the top face and the bottom face, just so I know what those are. Okay, so let's create a construction line down where each of those points are that I projected. And I'm going to create, let's see, I'm just gonna create a random circle here that's not a construction circle. And this is going to be the small handle diameter there. Okay, and let's say that seems about right to me. Let's pull up another sketch. Okay, so it's going to be lower than those other ones, which is fine. I think that's okay. So let's do dimension, right click, arctangent. And let's say 9. 9 seems like a nice round number. Now I want this to be about in the middle of these two. So I could use D42 so I know how far over from this line I need to be. Or I could project the points here and create a line between them and use midpoint. For this example, I'm just gonna be silly. I'm gonna right click, arctangent, select this. And this is gonna be D42. Done. Okay. Oh, wrong direction. It has to be on this side of the line. So by the way, this is a caveat you need to be aware of when you're using tangent constraints. So a tangent to a circle, if your geometry changes enough, you could find your circle on this side. The dimension. Oops. Okay, so the dimension could be the same, D42, but if the geometry changes enough, you could find this circle on the other side of the line, but this dimension stays the same. It could jump. Just caveat. Hey, Cruising Girl, welcome in. It'll make you go off on a tangent, like it just happened to me, Fern Dog. It just happened to me. So I can bring it over onto this side, and I can do a constraint here. And that works. But caveat, if the geometry changes enough, and this dimension is not very big, it's 0.7 millimeters. If the geometry changes enough, we could find the circle on the wrong side of the line, which could mess you up. Just be aware that that could be a thing. Okay, so while that works, it might be better for the sake of parametric modeling, we could just add, or we don't even have to add the line there. So I'm going to remove this, and I'm going to create a line between these two projected points. I'm going to create a line that goes down. Now, because the circle was already in the right spot, it already applied a perpendicular constraint for me. No, it did not. It was going to, but it didn't. I'm going to apply the vertical constraint on it. So now we can see the circle. It's hard to see the circle, but it's white now. And we're going to do the same thing to these other things. Okay, so we have a circle there. Okay. Create a circle here. I don't want it to be a construction circle. And this is going to be a small handle diameter. Okay. And I want the distance between these to be the same as this. So I'll just click on this. It'll use D47 as a reference. Okay. And because I don't have another driver on this side to be able to do the midpoint constraint thing, I'm going to select these. I still have my dimension tool selected. You can see right here. So I'm going to select these two dots. And I'm just going to create a driven. It's 14 millimeters. So now I can go here, add a point to this top area. And when I hit D, I can do a dimension between these two and just click on that. It's going to use D53 as a reference. So now I can add my construction line here. Get my circle going. Small handle diameter. Select this. Thanks for the follow, Jet Pinky. How's it going? Thanks for joining us. Okay. And now we want to add our lines at the sides of the circle so that we don't have, so it's not hard to insert our driver. Whoops. Okay. Up, up. Okay, so now we have those. Okay, so now let's do, which, by the way, a lot of times if my sketch is behind a body, like if I want to extrude and it's not letting me select my sketch because there's a body in front of it, if a part of the sketch is exposed, I'll select that, and then it'll allow me to select the sketch that's behind the body, because you won't be able to extrude anything that's not on the same plane. Hey, Foxy Ollie, welcome in. So that's why sometimes if there's something behind it, I'll just select another part of the sketch, and then I'll unselect it after I select more parts of the sketch that I want to extrude. Okay. So now let's do small handle length. There we go. All right, and now let's do our small driver shafts. So let's project these three. Whoops. Shaft diameter. If I select this, it puts D59, but I don't want D59, I want shaft diameter. Okay. And now let's add our lines. Let's make the body disappear so we can see better. And notice the dotted lines as I'm drawing. So I hover over the center, and then Fusion assumes, correctly in this case, that I want to create a constraint related to that point I hovered over. And so it's helping my mouse snap to the same vertical plane as that point, or horizontal, depending on where I'm going. And then I'll select my point here to make a line, and you'll notice it wants to apply a parallel constraint with another line. In our case, it's the line on the other circle here. You can see it right here. That line has kind of a faint cross line on it. That means that that's the line that's being referenced. So it's creating a parallel constraint against that line, and you can see there's a tangent constraint that will be applied between the line and the circle I just drew. So by just clicking up, and because I'm sorry I didn't explain that, because I went above it and then hooked my mouse onto this, it applied a perpendicular constraint between my line and that, instead of the parallel constraint between this line and this line up here. So you can pay attention to what constraints will be applied as you create your lines here. Okay, now I can just hit E for extrude and it'll finish my sketch for me. Okay, bring our body back. And now let's do negative small shaft length. Okay, so now all our small drivers will fit in those places, and then all our big drivers will fit in the other places. So there's enough space between here. So there's enough space on this side here that should be, was it 14 or 15? I can't remember. It's 14. So that's, the space is 14 millimeters from there to there, and it's 14 millimeters from here to here, and it's 14 millimeters between here and here, and it's 14 millimeters between here and here. Now if I change my spacing to 15, all those will change to 15, and theoretically, everything should expand and change accordingly. So let's try it to see if that works. I'm gonna hit save just in case. Let's go here, change our spacing to 15. Okay, let's remeasure. I'm gonna hit I to bring up my measuring tool. 15 millimeters. That's 15. That's 15. And that's 15. Look at that. Math is mathing. Hey, Maker Viking, welcome in. Thanks for joining us. All right, so that's looking pretty good. Now we want a lid to be able to close. Now, I could make this print in place, or I could make it so you use a thing of filament to push through all the I want to say joint. It's not a joint, is it? The hinge. That's what I'm thinking of. You can push it through the hinge with a piece of filament to make it a closable, or it can be print in place. What should I do? What's your opinion? Tell me in chat. Should I make it a print in place hinge? I mean, keep in mind, it's already 133 millimeters wide. So if I do print in place, it's going to be at least double that. So that's going to be bigger than a bamboo plate. Ah, yes. Yeah, good point, J. Palmer. Good point. No filament. So if I make it print in place, it will have to, well, what's the distance between these two? 205, so that's fine. If I do print in place, I'll have to print it on my H2D. It won't fit on a bamboo plate. But I do need to cut in finger holes to be able to access these. So let's do that next. What I'm going to do to make sure, because I want it to be right in the middle here, and I don't want to do math for that. Slide cover. Ooh, I like that. I like the slide cover idea. Okay. So I don't want to do math. I want the finger holes to be right in the middle here. So what I'm going to do is come up here under construction, and I'm going to choose mid-plane. Mid-plane, select this plane, boom, it's right in the middle. Now I can choose to do a sketch here, and I'm going to do an intersect. So anywhere these objects intersect with my sketch plane, it's going to leave a mark. Okay. And I'm going to do these edges as well, just in case. Just in case I need them, I'm going to make them construction lines. Okay. All right. So if I make the body go away, there's our profile. Boo math. Exactly, J. Palmer. Boo math. Okay. So I want a curve going this way. Maybe instead of this line, let's see if we can get an arc going. Do I want a 3-point arc? Let's do a center point arc. Whoops. I chose the wrong thing. Yeah, we still want a center point arc. We don't want it to be construction type. Okay, and so I'm going to click here, and let's just click here. That's fine. So we got our arc there. How deep do we want it, though? I think that's plenty deep. I think that'll be enough to... So let's do 11. Nice round number. That'll be enough to be able to grab it on each side, I believe. I don't know. Do I want 11, 13? Because we want enough space for our fingers to be able to get in there, right? And if my finger, let's measure my finger. Yeah, it's about 10. So yeah, let's go with 11. That's fine. Okay, I'm going to create a construction line here so that I can use that to mirror this. And I'm going to make these non-construction lines. So now you can see we can select that. Whoops. There we go. Now I'm going to select this, mirror, go to mirror line. I'm going to select this. There we go. Obviously, as we transpose this over, I don't even know if that's the right word. As we move this over, I'll just show it. So if I do a mirror over this line, you can see as I extrude it, there's just going to be this little sharp angle thing. I don't know if I want that. I'm wondering if I should just have a straight line that goes across the middle here. So instead of doing that, I'm going to delete these. Okay, let's do a line down the middle here. Now I'm going to do a construction line across here, and then a non-construction line that goes all the way over here. And now when I do my mirror, I'm going to do it based off of this line, and these are going to be my extrudes. Now without finishing it, I'm going to hit E. It'll finish my sketch for me, and I can do those extrudes. Now let's bring our body back. Now it's going to extrude right in the middle. But if I go one way, then it's no longer symmetrical. So over here, for the direction, instead of one side, I'm going to choose symmetric. Now, for measurements, you can do half length or whole length. In our case, it doesn't matter. If you're using parameters, you might care about that more. But I think, let's keep it at... How wide is my finger? It's about 15, 16. Let's make it 15. So if I want to do 15, note that I'm doing half length. So total, that's 30. So if I go over here and change it to whole length, that's 15 altogether. Now to give me a little bit more clearance here, I'm going to choose 17. There. So now I have my finger holes to be able to grab my drivers. but I don't want these to be sharp, so I'm going to first add a chamfer to these so that I'm not cutting my finger as I try to grab my drivers. I think 2 should be good, and I'm going to do a fillet on these surfaces, just so, again, I don't scrape my finger along something and have it be uncomfortable. I think 1 millimeter should be plenty sufficient for this. There we go. So, yeah. Now we'll be able to grab my drivers. Hey Pete Savis, welcome in. Thanks for joining us. A mechanical eject button. I'll just put a button right here, and then it's gonna be stiff enough to where you have to smash it with your fist, and all the drivers pop up, and you have to grab them all before they fall down. It's gonna be a game. Better watch out. We have your finger measurements. I just doxed myself. They know my finger measurements. Now here, as you can see where the shaft goes, that's going to be cut as well for when I do the finger things for these, and I'm okay with that. That doesn't matter to me. Okay, so again, we're going to do our mid-plane thing here. Okay, let's do our sketch. Do our intersect. Oh, and I also want to intersect these as well. Okay. Am I intersecting everything I want to intersect? That won't intersect. Okay. There we go. Okay, let's make our body go away so we have our stuffs. I don't want these to be construction lines. Okay, so again, let's do our arc, our center point arc. Okay, and this is going to be, what was it, 11? I'm going to create a line here. This will be a construction line, okay. And I feel like that's too big. It might not be a perfect arc because if my finger is fat, but I don't want to have to dig all the way down, you know, I'm just going to keep it at 9. I can always change it. Okay, so let's create a line that goes all the way through. Okay. Create our construction line in the middle so we can mirror this. Okay. E for extrude. Let's extrude all these, this hizzle. Okay. And again, we want to use symmetric. This, and what did we choose? 15, 16, 17? We chose 17. Okay. There we go. So the shaft, or the driver shaft of the big ones is going to go across these holes, but it'll still allow us to, but that's okay because it allows us to be able to grab the smaller screwdrivers on that side. Okay. Now what I'm thinking I should have done is I should have moved these to after we did this. So what I'm going to do, I'm going to highlight these, click and drag them on my timeline, and now my chamfer and fillet are on the side of the timeline after I did this extrude. So now if I double click the chamfer, I can hold down Control and now select all these. So it's still only one feature on the timeline. So I'm not adding another feature. It's all happening with one feature. Okay. Good, okay. And now for the fillet, we'll double click on that, hold down Control, and we can select all these. Now I did select those, that's right. I'm not going to worry about where the driver shafts go because my fingers aren't going to be there. Okay. That's going to be comfortable. Done. All right. Now, magnet lid would be good too. I do like magnets. 3/4 diameter. All right. Diablo's fun. I'm sure there's probably a CAD model out there of these tools. But that would be the easy way. I'm showing how to use various tools in Fusion. So if you wanted to make something that even wasn't this over here, you could, because you know what tools are available to make it. So even if there was an option where we could just import an STL or object and then just do a cutout, I wouldn't do that because that would rob you of knowledge. Magnets are cool. I do like Foxy Owlie's idea of a slide, like a slidey type lid to slide it on. And I think I might just do that. More magnets to hold the screwdrivers in. I do have magnets. That would prevent them from rattling around. Yeah, I do like that idea. So the lid, ideally the lid would keep them from flying out. The purpose of this is to travel with them. So I'm going to bring these with me to 3D Printopia so that I could use them as I'm setting up and taking down my stuff. And so I'll want to put them inside of a case. Now, obviously, I won't be able to bring these in my carry-on because I'm sure they'll probably be confiscated and I'll never see them again. So I'll have to have them packed in my checked-in luggage. But I do like the magnet idea, and I might just apply the magnet idea so that they don't fly out. If they're open and get knocked off, they can be held in. I don't know how strong the magnets are going to be because if it falls from a high point, the energy of the bounce back will most likely overpower the magnets anyways. But if I accidentally like bump it on the table or something, or if my hands are busy and I don't pay attention and I accidentally flip it over, then they won't go all over the place. So what if the screwdriver is already magnetized? It's not. I mean, there's a little, like, I've noticed that there's a little bit of, like, that they stick to it a little bit, but it's not magnetized. And I think that more has to do with if it's been subject to magnets before. But what do I know? I just work here. Oh, you tried to bring a metal toy hammer on a plane. Keyword try. There was one time I was going through customs and I had one of those, it was just a fingernail clipper. It was only about this big, but it had one of those file attachments on it. And they broke that attachment off because it was dangerous. I mean, I'm not going to argue what they feel is safe or not, but they broke it off. And fortunately, it's not something that I ever used, but the lengths they go to ensure safety is crazy. I'm sure it was taken away, and I'm sure you were devastated, Nick. I would have been devastated too. It could put an eye out. That's right. So I have, where's my kit? Oh, it's right here. So this kit is pretty nice. Talking about magnets. So this is the LTT kit. And, you know, it has all these drivers in it, and this has a magnet in it. So all of these get magnetized as soon as you put them in. I also have the LTT screwdriver here. which is also magnetic. And it even comes with a magnet piece here. So if I need to grab something using the magnet, I can. So I love the magnetized things. It's very handy. Which, by the way, in case you weren't aware, this tray is also magnetized. So you put screws and stuff in this tray. And also, I'm doing this backwards, so I can't remember which way I need to do it. Oh, it's that way. So you grab it, pull down, and it separates. So you can have this to the side as a catch tray for your screws and stuff, and then still have your bits over here. And then you can just, it's held together magnetically, so it doesn't just fall. It's very nice. It's not the cheapest of kits either. Oh, bearded at lttstore.com. That's right, Jeff Pinky. Yeah, when I bought my LTT driver, I told my wife that it was my Christmas present because it's a pricey driver. I think it's like $60 or $70, and then with shipping, depending on where you are in the world. And I bought it and I said, this is my Christmas present. Don't get me anything else because that's how much this costs. And she was like, what screwdriver costs $60? And so I had to justify myself by finding all the YouTube videos about it and people like comparing it and stuff and showing it to her. And by the end, she's like, okay, I can see it. Okay. It's really handy. I use it quite often. It's a ratcheting screwdriver and it has storage for bits, and it can even store bits that aren't LTT bits. And this one, a lot of people say they're competing with iFixit, which, they've come out and said that they're not intentionally competing with iFixit. They wanted their own screwdriver kit. But this end piece is on a bearing, and it's the smoothest bearing I've ever used. Like, you can make it go and it'll go like a minute straight. It's fantastic. Okay, so anyways, squirrel moment. Let's get back to this. Built-in fidget spinner. That's right. It's very fidgety. I love it. And if you haven't tried it, I mean, I'll spin it and I'll tell you when it stops. You can't hear it because of the noise cancellation of my mic, but I'll let you know when it stops. Okay, so I think I'm liking the slide-on lid thing, which means we're probably going to have some dovetail tracks here, and maybe at the end we'll have some kind of nub that it would require to click into. So I think I might just do that. It's still going. Still going, by the way. Okay, so let's just start a sketch at the end here. I'm going to do a projection of these sides. It's still going. It's slowing down, though. It's still going. Still going. Okay. I can feel it slowing down, so I'm paying more attention to it so I can tell when it actually stops, because it's so smooth it's hard to tell when it's moving. Still going. It's almost done. It's almost stopped. It just keeps going and going and going, and almost stopped. That's how good the bearing is. Maybe when I upload this VOD up to YouTube, I'll have a timer of how long it goes. Okay, so here, let's do our little dovetail thing. It doesn't have to be massive, but let's just do something like this. 45-degree angle, I think, is fine. And then let's do a distance of 10. I think 10 is excessive. 5. 5 might be good enough. And then let's do a distance here of 2. I can always change that. Okay. Now, I want to mirror this, but instead of creating a line here, I can actually use the origin. So if I select these, I can go over here to origin, make it appear, and then I can select this face. Whoops. Choose mirror line, select this face. Boom. It's mirrored. I didn't have to create a line in the middle. Woo! It's an infinite energy machine. That's right, Nick. That is right. Okay. Now I'm going to extrude these forward, but I don't want it to go all the way. I want it to go to a point and then have a little nub somewhere right here that it has to flex over to kind of give it that click and click into place. And the lid is going to come all the way to here, but the groove, I don't know what to call it. The thing that goes in the channel, because I'm very smart and know what things are called, will start at this point rather than at the end. Okay, so let's do that. And I'm going to, I've never done this before, so I don't know what clearances we want, but let's project these. And I'm just going to put a line here. And let's do, I don't know, 0.5. Let's try, well, it's possible it can easily flex because the bottom of the lid is going to be open. And this part is going to be open too. It's not going to be next to a part that closes off. So it can flex a lot. So I think we can do 1 millimeter. I feel like that's too much. Let's do 0.8 because we don't want to be too difficult, but yeah. Anyway, let's mirror that. So if I change it, it changes in both spots. Okay. Let's make our origin go away now. Okay. Now when I extrude this, I don't want it to start at this face, because this is where it's going to stop. I want it to click, then stop. So let's just do an offset of, I don't know, 5 millimeters. I think 5 is good enough. And then we'll do a distance of, I don't know, 3. I think 3 is okay, but maybe I'll do the offset of 7. Okay, there we go. Maybe I do want 5. I like 5. Okay, so we have this done, but I don't want this to be a right angle because when it comes in contact, I want there to be a slope so it eases into opening and flexing open like a compliant mechanism. So what I'm going to use is graft. So I'm going to select this plane for my pull direction, and I'm going to select this face and this face. And now I can move this open, let's say 45 degrees. I kind of like that. Boop, 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 boop. Done. So now that's nice. We'll have to make sure. Legit cool kid. Thanks for the bits. I appreciate that. I do like 5. 5 is nice. Now, the distance between this and this is how long I'll want the tab that fits in this groove. So if I want this to be closer to 5 millimeters, I could do math, or I could just fudge it and just say, there we go. So whatever. I want this same thing to happen over on this side though, but instead of just repeating that draft, I'm going to use this mirror function, or this feature, and instead of the object type being bodies, I'm going to choose features. And I'm going to come down to the timeline and select this draft. And then for their mirror plane, I'm just going to choose this. And instead of adjust, I'm going to choose optimized, and I'm going to hit OK. There you go. It's a nice 5 number. That's right, legit cool kid. That is right. Okay, so now we have our little nub that it will have to flex over to click into place. Now we need to add our lid. Now to add our lid, we want to make sure, because when we made our sketches for the drivers, the driver is going to be above this plane. So we want to make sure the lid isn't against this. So we want to make it tall enough. So what I'm going to do, let's show this sketch here. And I don't think I can do this. No, this won't work. But what I can do is I'm going to double click on this. And I'm going to create a line, a construction line between these. So that's right at the top of those. And now that I have that construction line, I can go here and click on plane at angle. Now I can click this construction line I created in that sketch, and my plane is right at the top of where the driver will be. Now we were pretty generous with our clearance for how the diameter. And so I'm confident that at this point, it won't interfere with the drivers, but just in case, I'm going to bring this up. But instead of modifying the sketch or this, I'm just going to do it as I create my extrusion. Okay, so there's my construction. And I'm going to create a sketch. Now I'm going to project these faces so I know where the box is. That way, if the dimensions of the box changes later on, because I'm using a projection of those sides, I can, if the box changes to be wider, these projections will be wider, and I can use that to make sure that things don't go wonky. Zarelf, welcome in. Good morning. Hope you slept well. Okay, so we want the lid to come up to here. So I'm just going to create, let's just create a rectangle here. Now I want, I'll deal with the clearance after, but if I do, I think 3 millimeters should be fine, right? 3 millimeters thick. I think 3 millimeters should be fine. So let's do 3 millimeters. Now, I'm also keeping in mind, I will need a clearance between this and my lid. So I could have it as 3, or I could have it as 3.1, because I'm going to give it, or let's do 3.2, because that gives it a generous clearance so it's not so tight when sliding it on. But wait, this is now 3. I have to change this to 3.2. Well, I'm going to remove that and just click on this so it references D87. So now whatever I change this is going to change over here. So we're going to do the same thing here. Select this. And I'm going to use this coincident constraint to constrain this line to this point. There we go, fully constrained. Now I could create lines and then try to build the box around this, or I could use the shell tool. I might just use the shell tool. But yeah, let's use the shell tool. So there's a few extra things we'll have to do with the shell tool, because the shell, and I use tool, but it's a feature. The shell feature will add shells on all sides. So let's do that. So I'm gonna create our extrusion, and the starting point, I'm gonna start with an offset of 0.1. So it starts up a little bit higher than where we started our plane. And to object, I'm gonna bring it down to this. I'm gonna say new body. it automatically tried to cut it because it saw that I was intersecting an existing body with my extrusion, so it assumed that I wanted to do a cut. But I'm going to change it to new body. Okay. Now let's make body 1 disappear. So this is what we can do with our shell. I can click on this and say 3 millimeters. But we can see right here, we still have this. This needs to be open. So I could just hit E for extrude, and then I could just bring that out here. Done. And that's fixed. The other way of doing it is by manually extruding just this top face and then extruding the walls. Either way, I feel like it's the same amount of steps. I feel like this is much more simple. Okay. So there's our little lid here to go on top of this. Neat. Hey, Big Jano, welcome in. Hey, Tech Jeeper, thanks for joining us. It's the king of floppy things. I don't know if I'm the king. I just adopted it. I saw someone else do a floppy thing. I'm like, I want to do that. And so I made a lot of floppy things. Okay. So looks like we have plenty of space here because we had the 2.2 millimeter clearance that we added. So that should slide on nicely. Now, if we grab this and move it, so this is the direction we want to add it. So we would just slide it on this direction, and then we have these things here, so it would snap into place. But we don't have the tab to go into that rail yet. We need to add that. So I'm gonna hit escape because I don't want to do that move. Let's look at the sketch that we made, this one. So we have this sketch when we made our rail, and we're going to use that to project onto this. Now, we want to start right here when we add our little tab. So I'm going to create a sketch here. And in fact, we aren't going to use that existing sketch because we could just use this profile. So we'll just do a project here and here. I'm going to make the ends here construction lines because I don't want those to mess with me. Okay. And now, so it's easier for me to see what's going on. I'm going to come up here and I'm going to select section analysis. I'm going to select this plane. Okay. And I'm going to pull it back just a little bit so I can see a little bit of that channel. And I'm going to hit OK. So that helps me see a little bit better. So now when I show the other body, I'm not blocked by that face that's facing towards me. So we have this projected and we need to connect this tab to this. So I'm going to use this intersect, select this face, and select this face. So now I have reference lines that I can connect to. L for line, I'm gonna click here. Now I could have used this offset feature on these two lines here, but it would have only brought it out. So I would have had to still attach a line to connect it to this. So I decided to just draw those out manually. Now I'm going to add, let's keep it at 0.2. I'm going to click on this so that stays the same. Okay, so that'll click onto that. Now what I'm thinking is because this is a point, it's possible that that might wear down more as it gets used. So I'm just now thinking I should have chosen to do that, that little nub that it needs to click past after I did this. So we'll have to do some changes here. But I want this to be about 1 millimeter high. So this is going to be our profile for it. I'm going to select these. In fact, let's trim those off. T for trim, excuse me. T for trim, I just trimmed those 2 lines off so I didn't have to deal with them. I double click to highlight all the connected lines. I'm going to choose mirror, select a mirror line, and because I didn't create a line here, I'm just going to make our origin come up and select this face. Now my origin can go away, and now I have the same thing on this side that just got mirrored. Okay, I'm going to hit E for extrude. Okay, now one thing I can do to ensure that the lid doesn't rattle back and forth as much is I could add a parameter that determines how long this should be. And in fact, I might just do that. Let's just do that. I'm gonna hit cancel. Let's finish this sketch. We're gonna go back in time for a minute. So, back when we did these, we did a draft, but we did it based off of this plane. What I think I might do is add a plane on this side, so when I do the draft, it's easier to determine the angle, or it's easier to determine the length here. Right now, you can see right here, it says 5.329 millimeters. I want that to be whole. And because of this draft thing I did, I'm gonna roll timeline back here. Because I chose this surface to be my angle, my pull direction, it made it imprecise. But what I can do, I'm gonna step back one more time. I'm going to create a plane at angle. I'm gonna choose this line, 90 degrees, so I can use that plane. And now when I step forward again on my timeline, I'm gonna double click this. I'm gonna hit this X next to pull direction, and I'm gonna choose this instead. Okay, and so you'll see right now it's this long, and when I edit it and change the pull direction, it gets a lot thinner. But now when I click on this, it's exactly 6 millimeters. So I can use that. Now I'm going to adjust this to be 5. And I want the distance, let's the distance be 5 as well. Nope, 4. Let's go 4. I like 4. There we go. So from here to here, this point to this point is 4, but because we did our draft and this is at an angle, this is now 2.657 millimeters long. Okay. Now I want the tab that I'm making on the lid come right to about right here, maybe in the middle. I want it to be able to hug this and this. So let's make that go away. I hit V for visible, or I think that's what it's for. Okay, this is not liking it. Oh, it won't work because it's because there's no plane on this side, I think. Let's see, mirror, error, compute failed. No pattern instances could be intersected with the original body. Is that so? Let's do this. Will this work? Nope. Okay. Let's go back here. Roll timeline. Let's delete that. We'll just repeat this. Plane at angle, 90. Draft. These two faces. 45. Whoops. Flip. Go. Okay. Now, I probably want this to be a little bit further out because I did determine that it was about 1 millimeter. So the distance between these is 0.8, so that's less than 1 millimeter, so it's not even going to interact with this at this point. So I believe we want to adjust this to be, I don't know, so it's going to be 1 millimeter, and then there's a 2.2 millimeter buffer. So if I do 1 plus 0.2 plus 0.5, 1.7. Sure, why not? That seems a bit excessive, but hey, why not go with it? Let's change this to 5. Let's change it to 6. I like that better. 6. Okay. That's looking better. See, I've never done this before, so we're kind of flying by the seat of my pants at the moment. Okay. Okay, let's jump to the end here. Okay, so now we have this. Let's grab our section view and grab our sketch. Okay. Let's extrude this. We want to offset because it's right up against that wall and I don't want it to interfere with that. So let's just do 0.2 millimeter offset. And we want it to be, what was it? Did I choose 6 millimeters before I did the draft? So let's do 6.4 millimeters. And it'll want to join with body 1. I don't want it to join body 1. So let's get rid of this section analysis. So that's where that is. Okay. I'm going to adjust this section view so I can see a little bit better what's going on. Let's have it be right there. Okay, so you could see that's where it ends. Let's make it a little bit longer. 7. Okay. Hit OK, bring it back. I don't want it to merge. I feel like that's too far in there. So let's adjust this again. Let's go 6.8. Yep, that looks good. I'm going to make body 1 disappear so that when I do the join, it doesn't join the lid to the body because this face intersects with the body. I also want to change this a little bit. So let's change this sketch. I want this to be, let's go 1.4. Okay. Okay. I want it to intersect it just slightly because I want it to be snug. I want it so when it clicks into place, it'll still kind of be hugging the other side of that tab or of that little nub that we created. So it won't rattle. That's what I'm hoping for. All right, TechJeeper. Okay, so let's keep it at that. I'll have to do a test print to see how well that fits. I'll probably just have to print like just this part of each piece so I'm not wasting a ton of filament till I get the fitment just right. But that's hopefully how it'll work. I feel like that's not a lot of clearance here. Ah, that I did that wrong. So, let's see, when did I do that extrusion? I'm going to change this extrusion. So instead of just one side, I'm going to do two sides. One side still goes all the way to that. Let's go distance. And I want this to be 3 millimeters, right? And then this will be to object here. New body. Okay. Now I need to redo this shell feature to make sure I do this side of it. Okay. All right. You can see there's that little clearance between the top of the driver handle and the top of the lid. Okay. That's better. I thought that looked a little fishy. Okay. I don't care about that gap there. I just want them secure. Cool. Let's save this so we don't lose any work. Try to slide it on and it just runs into the drivers and you're just like, oh, well, I made a mistake here. So that should work. Plus, I made the clearance of the driver handles pretty generous, so it's still going to be even lower than that when they settle in. Now let's make this a little bit more friendly to handle. Now I'm going to add a chamfer on the inside here. Mostly because when I add a chamfer to this outer corner, I don't want the corner here to get really thin. So I'm going to add a chamfer to the inner corners here. And because of where the drivers are located, it's not going to interfere with anything. Let's do 1. Yeah, that looks good. Okay. And now because it's 3 millimeters thick, when I do a chamfer on the outside, I'm going to do 4 because 4 plus 1. Now, you don't really, or 3 plus 1. Math is hard. Oh, it doesn't do it the same way that a fillet does it. So let's do 2. So I kind of wanted the distance. It doesn't matter in this orientation, but so say for example, I'm going to show an example of what I was thinking. So if I have a rectangle here, let's do this. Shell free. Okay, so if I have a box here, and I do a fillet, and I think I said 3. If I do fillet and I choose 3 here, along the outside, let's do a bigger number like 5. That's too big. 5. Notice how much closer the corner gets to this outside. Now, when you're 3D printing, oh, hey, Shenanigans, welcome in. Now, when you're 3D printing, the extrusion width doesn't vary that much. Like, usually, if you're using classic walls, the extrusion width is going to be the same, probably 0.4, 0.42 or something like that. Hey, thanks for joining us. I am Peckinpah. Thanks for popping in. And so when it gets to this corner, it's going to do some interesting things to fill that in, and there might be little tiny gaps with your extrusion because it has to like stop and fill it in weird. If you make it so that the distance between this inner radius and this outer radius are the same as the wall thickness, then no weird things have to happen while you're 3D printing. It can just easily extrude that without doing some weird jumping things. So because the wall thickness is 3 and this is 5, to get the inner, it's 5 minus 3, which is 2. I mean, the math isn't hard, but I'm just going to do that as an example. And if you look at it at the top, it's going to be if you're doing single lines of extrusion with your 3D printer, you'll do one extrusion here and another extrusion here, and it won't do anything weird. So that's kind of what I was thinking about. But because of how this is going to be printed, that doesn't matter. But I just think it looks nicer when the dimensions are friendly like that. Okay. So I don't think I did this properly. That's 3.5, whatever. But I just wanted this to look nicer, and to make sure that the corner didn't get close to the edge here, I just added a chamfer on the inside here. Okay, that looks good. Now I'm going to add a fillet. Now I don't want to add a fillet in here because, as you can see, I mean, I could add a fillet, but I want to make sure the fillet doesn't interfere with this. And this, I think, what was the radius here? 3. So if I do a fillet, I can do 3, and it'll still be in the inside there. It shouldn't interfere. But I'm going to do 2 just in case, because you never know with 3D printers if there's any over extrusion or it does something weird, or if the acceleration is too high, or you don't have your not input shaping, your pressure advance set properly. It could make it so that corner is too gummed up, and so this won't fit in it. So I'm going to be generous and just only choose 2 on those corners. And again, like I was showing earlier, the distance between these is 3, and if that's 2, I'm going to make this 5, so that it's an even extrusion around this rounded corner as I 3D print it. Okay, now I'm going to add a chamfer to this because those are pretty sharp, and in case it like catches on me, I don't want it to. I'm gonna be generous with that one. Okay, and now let's add, a fillet to this outside here. 1 millimeter, I think, is plenty. Before I do that fillet, though, I'm going to step back in time. I want to put a chamfer on this, but I'm not going to do it as big as this one because there's not a lot of material here. Oh, thanks for the follow. I appreciate that. I am Pick and Paw. Okay, so I'm going to put a chamfer on here, but I think I'm only going to do 1 millimeter, just because there isn't a lot of material here. And now I can step, and it'll put that fillet on it. So that looks like it'll be nicer to handle. I'll put another chamfer on the bottom here, just because I don't want it to be uncomfortable in the hands. I might have to do it before my fillet though. So let's step back in time. Do another chamfer right here. Okay. Would 1? I think 1 is good. Okay, hit OK. Let's step over, and there's our fillet. Okay. Neat. Now, I could put a design here, but this is the face it's going to print on, and I was thinking of just using a 3D effect sheet to print that, so it kind of looks neat. I could still like add paint on some kind of logo or something, and then have it be a multicolor print, which I think I might do. Do you guys want to see how I would do that? Hey, Polymorph, welcome in. Thanks for joining us. So I think I could put LDO's logo in the corner so we know that it's LDO's drivers, but I kind of want to put my face in another corner. Or maybe I could just put my face right here with LDO in this corner. I'm not sure what to do. So let's go here. Insert SVG. Let's find my face. Okay, profile picture, logo. Let's choose that. Okay, so there's my face. And I'm thinking I kind of want this I could probably put it in this corner, and then I can put LDO's logo in this corner, because I look up to LDO. I think that's good. Okay, and I haven't looked for, let me see if I could find an SVG, LDO Motors SVG logo. Let's see. Here's an image. I could probably convert the image to an SVG. Does anyone have an SVG of LDO's logo? Or do I need to create one on the fly here? Yeah, let's open up Paint. Hey, Polymorph. My day's been actually pretty chill today. Not a ton going on at work, like still doing work, but wasn't very stressful, so it's been pretty nice. Okay, so let's do new. Okay, that's the logo that I just downloaded. I'm going to paint this black and white so the conversion is better. And I'm going to select all this. Go to crop to selection. Let's save this. PNG, that's fine. Okay. I usually go to convertio.co to do my bidding when I'm creating SVGs. Oh. There you are. Okay. Let's see how good it does this, because that's kind of a low poly picture. Could have found a bigger one. Okay. All right, so let's go here, insert SVG, LDO. Did I miss it? There you are. That's not too bad of a logo. Okay, let's put you over here. That seems about a good spot for it. Okay, so I'm going to extrude about 1 millimeter in. Okay. And now I'm going to extrude back out, but I'm going to choose new body. Now notice for extent type, I chose to object and I just chose the top surface. I just do that often because I'm used to it. Okay. Now what I'm going to do, so it's easy to export that, I'm going to create some components. So LDO component, I'm going to uncheck this because I don't want to activate it right away. And let's do a BP logo. That's good. Okay, so nope, not that one. These two. So I'm going to drag those down to LDO. And I'm going to drag these down to BP logo. Okay. Now, let's see. Do I still have... Let's bring this back up. We'll bring back up that logo. Oh, no. No. Because I didn't save it as this color. So I'm going to grab this value here. Where's the hex value? Here it is. Oh, you couldn't see that because I'm covering it. It's over here. This window. So I'm grabbing this hex value so that I can go here. And I'm just going to drag blue over to LDO, but I'm going to edit it. Advanced. Let's edit this. Put in my hex value. So that should be close to LDO's color. And I'm just going to do black for BP logo. I don't think I have this color as a filament, but just for fanciness. And let's make these pieces gray. Maybe I want them dark gray. Do I have a dark gray here? I could just make it darker. Or edit. Let's do that. That looks good. Cool. Okay. So now I'm going to move these. Rotate. Let's just rotate it along this axis. And I'll make sure I have these selected too. Whoops. So I'm going to save these, but I want to make sure they're saved in the correct orientation. So it's easier for me. Okay, so there's my two objects. Let's save this. All right. Bottom. Top. Okay. So now I'm going to right click, save as mesh. I already have my refined settings set to high. Hit OK. Let's go to our STL folder, new folder, LDO driver case. Save. Oops. Hit save. Okay. Yep. Save top. And now I can right click on a component and save the whole component. So if the component has multiple pieces, it'll be saved as one STL. You can't see it because I'm covering it, but I'm just here. Let me bring this. So I'm just right clicking on this and then clicking on save mesh. So it does it for the whole component. All right. So now let's open up Bamboo Studio and paint it, and we can send it. I don't think I have the right filaments in there though, so I'll send it after we're done here. Yeah, shenanigans. So I have to bring some of these drivers with me for part of my setup at 3D Printopia, and instead of just putting them in a baggie or letting them float around in my suitcase, I thought I would design a case. And in my very quick and my hasty research on cases, the only LDO driver models I could find on printables had to do with like attaching it to a multi-board or honeycomb board or something like that. And I just want a case by itself. So that's why we're designing one. So anyway. Okay, so we could let's use the X1 carbon. Let's choose this. Delete you. It doesn't let me put in a hex value. That's great. We'll just do this color for that. Bamboo, basic. And this one's going to be black. Okay. Now, when I import it, let's go to our driver case. I can do top plus logo plus LDO logo, open. And when it asks if I want to upload these as a single object, I'm going to hit yes. And now, if I go over here and choose objects, I'm going to make my face disappear, by the way. Just so you can see what I'm doing over here. Okay, so now I have 3 objects. So even though I uploaded them as 1, I have 3 objects. And I can just click on BP logo and hit 3 on my keyboard, and I can hit LDO and hit 2 on my keyboard. And now when I look underneath, that's how it's gonna print out. It's gonna print with this blue, it's gonna print with this black, and this dark gray. And I'm gonna print this on a 3D effects sheet, and there it is. I didn't have to upload any SVG and do any weird things with print sequence or anything. I just upload it and I just choose what number each part is. Okay, and then let's have another build plate so we can have the bottom. Okay, so before I send this, I'm gonna want to test the tolerance and the fitment of this, because it's the first one I've done, so I don't trust that my numbers are where I want it. So I'm just going to cut this, so I can actually do that right here. So I'm going to go here and click on cut. Whoops. And I'm going to rotate this and then drag it so it cuts that. I want to keep the blue part. I don't want the magenta part. So I'm going to unclick this, but I also want to keep orientation. Sometimes it reorients it in a way that I don't like. In this case, I think it should be fine, but I'm going to check it anyways, just in case. So I can perform cut, the pink part goes away, this part stays, and I'm actually going to change this to 1 as well, because I don't want to do a multicolor print on a test. Okay, and I'm going to do the same thing over here. I'm going to cut this, rotate this sideways, drag this up, make sure that this is still visible so it can clip over that. And then I'm going to make sure keep orientation is selected, perform cut, and now I can drag this over. So that's going to be my test print. And I think I have white in there actually. I do have white in there. Okay, so let's just choose white. And because I want it to be a faster print, I'm going to change this to adaptive cubic. I think 10 is fine. I don't care about the quality, so I'm not going to add wall loops or top shell layers or anything. I only care about this part. So, and because I chose 45-degree angles, there's no overhangs. Now I'm going to double check that there's nothing on my build plate, because last time I just sent, oh look, there's something on my build plate. Last time I sent something, I had something on there and it was like breaking things. So let's fix that. There we go. Which, by the way, I got something I want to show you guys that I did today as well. Okay. Let's send our print. Oh wait, hold on. Yeah. When I change it to a 3D effect sheet, I make sure I have these 2 things disabled, because if it tries to do AI monitoring and the plate is somewhat shiny, it messes with the camera. So I disable this, and because the plate I'm using as a 3D effect sheet doesn't have a QR code, I uncheck that as well. First layer inspection is garbage. I hate doing that. And then, yeah, let's just keep flow dynamic. I don't think flow dynamics does anything, but it makes me feel better when I send it. Make sure it's textured. Yes, it is. Cool. All right. So, yeah, that was a little bit more involved than I was expecting, but it looks pretty good. Hey, Ram, welcome in. Thanks for joining us. Right. Okay, so I designed this thing today to be at my table. Now, this logo is a transition type thing. The color transitions from like magenta or purple to orange into yellow and stuff. Obviously, I don't want to do like a Hue Forge thing with it, so I did the best I could with how I did the colors here for Panchroma. And this is the Fiberon logo, and then this QR code is to my affiliate link if you want to purchase Polymaker using my affiliate link. So I thought I would have this at the table with me at 3D Printopia. They sponsored the filament. Why not have stuff to be grateful for, being sponsored, with the filament for the Dummy 13. So, yeah. So I just did that today. It was relatively easy. You'll notice there are 6 different colors on this, but it was printed on my X1 carbon with only 1 AMS. It was interesting. So what I did was I loaded white, black, this teal, and orange. And then when the white finished, this is raised. So I used a combination of multicolor printing and color swapping. So when the white was finished, I had it pause, and then I swapped the white out for yellow. And then when the black was finished, I had it pause, and I swapped black out for red. So the slicer thought that it was swapping to black when it was finishing printing this, and it thought it was swapping to white when it was finished printing this. But because I switched the colors mid-print in the AMS, it just sent it. And that's how I got 6 colors with just 1 AMS. Yes! I'm glad it works. Thanks for double checking that for me, Peekaboo. So, yeah. All right. Okay. I lied to my printer. Oh, this thumb is broken. He's got a broken thumb. There we go. This dummy is number 1. Not this dummy, this dummy. Yep, that's right, Additive Adam. Yeah, you can, and I've done it several times where in the slicer, I'll only have 4 colors assigned, but I'll put color swaps or pauses at various stages, and I'll just switch it back to a different color that I had already used, but then I'll just swap out the filament colors as the print goes. It can be a little complicated, and if you forget what you're doing, it can get a little messy. But this, excuse me. Whew. All right. Yeah. So there we go. Number 1. Anyway, so thanks a lot for joining me. Does anyone have any questions on what I was doing in Fusion before we call the stream?